Okay, hi, welcome everybody. I think we've still got a few people will join us as we proceed, but we'll kick things off anyway. So welcome to the Sydney Modern Apps Meetup group, covering a couple of very interesting topics today. First up, we have got Rod Hemphill, who actually runs our sister group in Melbourne. And he's going to be telling us all about building web apps with Blazor. So I expect a fair few of you are here for that. And then I also expect we've got a fair few to listen to Priyanka Gyawali's talk after that, which will be all about the latest developments in iOS 14 and Xcode 12. Now, normally at this point, I'll have a bit of a summary of industry news, but then I figured there'd be quite a lot of overlap with that and some of the stuff that Priyanka is going to be telling us about a little bit later. So with that pretty much means this is quite a short introduction this time around, and it's time to hand over to Rod. So bear with me for a few seconds while I get the screens switched over. And as soon as he is there, which will be in about 5 seconds time, we can actually do the handover. So Rod, you're up on my screen now. So by the time I finish saying this, you should be on everybody else's. So over to you.
Thank you very much, Alec. Let me get straight into it. So we're going to cover building web apps with Blazor. So I'm not assuming that anyone that's listening has knowledge of Blazor. So I'm going to explain what is Blazor and how it works. I'm aiming at experienced professionals, so I'm not taking a basic level, and I'm aiming at people that are used to building high quality, large scale systems, because that's what Blazor is aimed at. Our aim at Melbourne App Development is high productivity. So that's one of the main reasons that we choose Blazor over Angular or React. And we also have a focus of combining web apps with mobile apps. So the agenda tonight is I'm going to cover the basics of Razor Pages, which is the UI component of Blazor. I'll explain what you don't get out of the box when you new up a new solution with Visual Studio. I'll go through our architecture, and the last bit I'll cover off how to share code with your web app across to your mobile app using Xamarin. The demonstration, so I'm going to demonstrate a couple of apps here. So the one that you see on the screen with the motor car on it is the Motorsport Australia event entry system. So about 4 months ago, this was the largest live Blazor system in the world. I'm not too sure if it is now, but it certainly was then. It's quite large, about 50 pages, took us about 4 months to build, about 5 developers. And I'm also going to show screens from a simpler app, because a large app like the motorsport one is just too hard to demonstrate in such a short time. This presentation will be recorded. There's a lot to cover, and a lot of your early questions are going to be answered further in the presentation. So I ask you to leave your questions till the end. And this presentation pack, which actually has our architecture diagrams within it, will be available. I'll give that to Alec and he'll distribute through the meetup. And there won't be any repo distributed. We normally, at Melbourne Meetup, we normally distribute repos, but these are all client sites, so there won't be any of that. Let's get started. So Razor syntax is the language of Blazor. Basically, it involves 2 concepts. So first of all, it combines HTML with C#. And the second concept is that you can create your own HTML tags. So I'm going to show you that with one of these screens. So Alec, we can see that okay?
Yes.
Yep, cool. So I'm just going to grab an HTML tag. Let's take table. Oh, I've got mfractor turning on, and it's going to cause me a problem. So there's a simple HTML tag. Now what we're going to create is one called a modal page. Now what I've done on the right hand screen there is actually created a file called modal.razor. So that IntelliSense came up on the left simply because I created the file. The syntax of the syntax of Razor is this. There's @code. So at the top here we put our HTML, and in here we put our C#. Now I'm going to create a modal page. So what I'm going to do is put up a card on our page. It's going a bit slow. So I'm going to put up a card, and within that card, later on we're going to put some information. And that's it for the moment. Now, if I look over on the table here, so what we all know about HTML is that you can add parameters. So in table, we can add border equals 1. We can do the same thing over here. How we do that in Blazor is I'm going to create a public bool is visible. Get set. And how we make it a parameter is we put a parameter attribute on it. Now, when we go over here, we can go is visible. Visible. Oh, IntelliSense. Hurry up. So I think the speed problem is due to me streaming at the same time, because I went through this a few minutes ago without a problem. So I'm not too sure what's happening here. I'll apologise and keep moving. Now that allows us, now that we've got a parameter called is visible, we can actually do some C#. If is visible. So let's move on to the next bit. So you can see now that I've actually put in the @ symbol, which means that in my HTML section, we're going to break out into C# code. And then within there, we embed HTML tags. And this mat card is an HTML tag provided by Blazor. I'm going to cover that off further in the presentation. Now with a table, we might want to put a table row within that. Now how we do that with Blazor is we create another parameter where's my IntelliSense? Render fragment, child content, and then what we can do is say at child content. So what that means is that whatever tag we put in the middle here on our left hand side, so I'm going to put a table in there, then that would actually put a table up on our modal page within this, in between a card. Now the only other thing to add here is is we're going to put some CSS class equals modal page layout. Modal page layout and another div. Now these will become obvious why I'm doing this in a moment. And the other one is modal hyphen content. I'm going to put the mat card in between that, and IntelliSense should tidy that up. There we are. So what I wanted to demonstrate here is that we've actually now created an HTML tag called modal page. So Blazor is used for two purposes: to create HTML tags, but also to embed C# with HTML. So you can see up on the left-hand side there, I have the if test. Basically, you can put whatever C# you like within, mixed in with HTML tags or component tags. Now I wanted to, let me quickly go and show you a more complicated page. One of these is, nope. Why have I? Sorry, I am absolutely amazed at how slow this is going. So that's that one. It's TechFlix Web. This is Platform Web, and this is the CAMS one. So this is the Motorsport Australia one. So I'm going to show you this page in a moment, but it's about 400 lines of code. It's quite large, and you can see right from the start. So it's C# with components or HTML tags within them. Up the very top, we have the two lots of navigation. So this is how you navigate to this page. We have an inheritance if we want that. We have using statements. Basically the same stuff that you'd see in C#, just slightly different syntax. You'll notice in the section here, there's quite a big slab of C# code. The other thing that's worth pointing out is that whereas on the component we had the @code syntax, to put C# code. Here we have, what we do is we have code behind. So if I look at each of these, so this one's called the event setup. There it is there. We have, that's a Razor page. Behind that we have razor.cs. Exactly the same as we see in the mobile development environment. And I'll come back to that a little bit later. I wanted to show you this page. So if I look at this, this is a system that manages video broadcasting out to the people that are fixing the power lines up in the fire areas up in Queensland. So these are pages within a bigger page. Now I'm going to click on this plus button over here, and this brings up that modal page that we just saw. So the CSS that I put in there, all they do is say, what's this area? What proportion of the screen is that area? And what proportion of the screen is grayed out? And which areas are we allowed to click into? And you'll see that in this case, this is the content within that modal page. How we got started with Blazor is that we had a large project to do. We had the option to use React was our first choice, and then we realized when we got down to the quoting process that React was just going to be far too expensive. Blazor came on the scene. It was about 3 months before it was production ready, and we said that we would go with that. What we decided to do, and this was a very fortuitous decision, we decided that we would use the material design, which we were just using with our iOS and Android to get consistency across them. So we decided on material design for Blazor, and we came across this product called Blazor. And Vladimir put together large amounts of basic functions in a material design manner, and he provides them for free. So on the screen at the moment, we see the name field. When I click into it, the name becomes a label at the top, and then we type in our stuff. And this is a drop-down list. All of that material design or Blazor functions. So if I have a look at his site, this is worth going to. So here is his site. I'm going to look up the text field, and a bit slow. And if I scroll down on the text field, what he's got is, what I should say is those parameters that we saw when I created that modal page, that's what all of these are. These are all the parameters that he's built for his text field. Quite a lot of them. Here are some examples. So he's got, so you can actually play with this and change the parameters and run the code. But as you can see, there's lots of different styles just for an individual field. This is the one that we use, which you saw before. Actually slightly different. So ours, the label goes right up in there, although that might be a bug. But we strongly recommend that, we use Blazor, and we recommend that other people do as well, because it saves a huge amount of work. It gets consistency across your web pages without a lot of stress. Now I'm going to switch across to the event entry system. So this is I'll leave this page. So this is the Motorsport Australia. It's a simple list. I'll go into this event. Now, you can see in here that each of these fields here are Blazor fields. You can see the copy up there, drop-down lists, etc., etc. Now, what we do and what I recommend other people do is grab something like Blazor and make them your own. So what we do is we wrap an entry field, the Blazor. Oh, that's a bad one. It's a drop-down. So we grab, we go back up here. So this is an entry field. If I delete that and tab out of it, there's an error message there. So we've wrapped the Blazor component and added our features to that. So in this case, we've added an extra label under every field called validation, and we use fluent validation. So later on, I'll show you in the actual code how you implement that. But yes, so you'll also notice that each of these 10 items here, they're obviously accordion panels. So this is the accordion panel, is a Blazor accordion panel, but this section up here, where we summarize when the panel is closed, what the content of the panel is our addition to this component. Now the code that I showed you before as an example is was actually this page. So this is that page. So you can see in here, here's the mat accordion. We have an expansion panel. So the prefix MAD, you'll see that a bit. That's because a company is Melbourne App Development. It's not because we're crazy people. It's just our name. And so you can see in here, there's hints that this one's actually, well, actually anything with a mat in the front will be Mat Blazor, and anything else will be our components. When you come to building a large system, you don't need to spend a lot of time working out what your components are. In our case, there's 50 odd pages, I think 3,000 lines of Razor code, and yet these are the components that we've used. In fact, we only use 2/3 of those, so it's not actually very many. So I wouldn't go overboard pre-planning what your components would be, because we built them as we went, and probably we've only needed to address maybe 10% of them. Moving on to client side, moving on to Blazor. What is Blazor? So there's two flavors of Blazor. There's the server-side Blazor and client-side Blazor. The productivity of Blazor over React and Angular basically comes from not having to use JavaScript. Now, how it works without JavaScript is what I'm about to show. So there's two flavors. There's the server-side Blazor and the client-side Blazor. On this diagram, I have the browser, so this is Chrome or Safari or whatever, and down the bottom is your actual Azure server. We build the project build the solution that I'm showing you examples of on the server side. So if I'm looking at server-side Blazor, I build it there. The Blazor code generates HTML, so it converts that Razor syntax into HTML, and then it sends the HTML to the browser, and the browser treats it as basic HTML. Now, the communication mechanism between the browser and the server is over a thing called SignalR. SignalR, in fact, there's a link down the bottom for more detail on SignalR, but basically all SignalR is a socket connection, a continuous socket connection between your browser or the client's browser and your server. It actually does a lot more than that, because it gives you, I think of it like a virtual machine per user on the server side. It's not, but it's how I think of it. So your memory space is protected or isolated on the server side. Because this is a continuous connection, a continuous socket connection, the response time from a communication from the browser to your server is very, very quick. So I timed it in my environment here, my development environment, it's less than 10 milliseconds. The benefit of that, a classic example of that was if you were putting information about a car and you have to put the make and the model and the other components of a car, when you select the make, you want the drop down of the model to be restricted based on the make that you've chosen. Classic example. What happens on a normal HTML is if you went back to the server to restrict that list, then the HTML delay in doing that makes it absolutely useless. So what we've been doing for the last 10 years is using JavaScript. So we pass the entire list of the model to the HTML, and we use JavaScript to do that restriction. With SignalR, you don't need to do that. So what we do is we say, all right, the make is a forward, and we go back to the server, change the drop down of the picker list of the second to all of the forward models, and and redisplay them and tell the browser to rebuild that. And that happens so quickly that it effectively gets rid of the need for JavaScript. Let me explain the client-side Blazor. So the client-side Blazor is very different. All browsers now, all modern browsers now, have WebAssembly built into them. So that's effectively an operating system. Now, what Microsoft do is they grab their Mono runtime, which is the same or a version of the Mono used in our mobile environment. They have created a WebAssembly version of Mono. We build our code, Blazor code, and creates a DLL. When a user clicks in the browser on your URL, it makes a request back to the server and loads the whole DLL, including Mono, into the client's browser and runs your code within the browser. If your code needs database access, which most of us do, then we write the code to make a REST call back to the server to get that data. The other thing to note about this is that the DLL, if that's very large, then it takes time to load that into the server. So there's a couple of links there, SignalR and WebAssembly. The pros and cons of server-side and client-side. Server-side versus client-side. So if you're running client-side Blazor, then you're limited by the compute power of your client's computer that it's running on. The disadvantage of server-side is that SignalR causes a continuous chat between the browser and the server. So if your internet coverage is dodgy, then server-side is not the solution for you. So in our case, if anyone's got a client, say a mining client out in the middle of Western Australia, then you certainly would not be using server-side Blazor. You would choose client-side for that. In our case, we have lots and lots of racing car drivers. They don't have great computes, so client-side server would not be a good choice for them. Secondly, client-side Blazor is still maturing, so it doesn't have thread processing. It's only recently got debugging. In fact, the client-side Blazor debugging experience is still quite poor. 7 days ago, Microsoft said they had fixed that and they've got a better experience, but I still haven't been able to get it to work. Performance of this is not a performance of Blazor, this is a performance of WebAssembly. The processing of large amounts of strings, or large amount of string processing, is actually quite slow in WebAssembly. So it really depends on what you're trying to do as to whether you would use client-side Blazor or server-side Blazor. Certainly we would not be pushing a major client-side out on client-side Blazor at the moment. And I also mentioned before that one of the problems that the Blazor team are working on is how to make that experience of loading the first DLL or the DLL the first time, make that quicker. What we do. So we actually build a dual server-side, client-side Blazor. So I can probably show you that, not on that project. Not on that one, I'm sorry, I should have organised which ones. Yes, on this one. So we've actually got 3 projects here. We have this TechFlix project is a .NET Standard project. This is also a .NET Standard project. So this is the client-side Blazor .NET Standard project, and this one is a .NET Core project. So most of our code is in the main .NET Standard, and we share that across client-side and Blazor, client-side and server-side. And the only other difference is that on our server-side Blazor, we also have the API, the controllers that we use as our API, which I'll cover a little bit later. But this gives us the benefit, if you look up the top here, when we build a project, we can build obviously release build or a debug build, but on debug build or release build, we can say build it as a server-side Blazor, build it as a client-side Blazor, or the top option, debug, that actually builds both. So it builds the server-side Blazor, it has a reference to the client-side Blazor and builds that as well. And longer term, we can actually switch dynamically. So if you can build a release build that has both server-side and client-side, by executing a different URL with the client, you can actually swap from client-side Blazor to server-side Blazor. Although that's certainly not recommended, but longer term, that's where we're going. So I'm going to cover now the architecture now that we use. Now I'm going to show you the next few slides. So if I scroll down here, there's another 3 slides, and then I'm going to come to that same architecture diagram. So I'm going to gloss over it here and then fill in the blanks when we get to the second instance of it. So this diagram represents the client side. So on a Blazor, it would be the browser, and on the mobile would actually be the mobile device. And then we have the server side. So this is the Azure server. Now within each of these, we have a 3-tier architecture. So we have a data tier, a business logic tier, and a user interface tier. And we have that on all of these green boxes. Now, you'll notice that the view model we've got in the user interface tier. I want to focus on that because this is not MVVM. So the MVVM pattern, we use the MVVM pattern, but we also use a 3-tier pattern on top of each other. So this diagram represents a 3-tier architecture. There's other diagrams that I can show you where we represent the MVVM pattern. So by 3-tier architecture, I mean that we distinguish between the data layer and the models. Now, the reason why we do that is that when you get into any large-scale app, then you need to distinguish between the two because they will be different. Certainly on the mobile side, or actually maybe not so much on the mobile side, but certainly when you convert a desktop app to a Blazor app, it's absolutely certain that they're going to be different. So our architecture allows for that. So I'm going to cover 3 different things and then come back to that architecture again, and hopefully it'll make more sense. So the MVVM pattern in Blazor. Blazor provides, out of the box, it provides pages and the code behind for those pages. It handles property change event handler, similar to in the mobile, it's iProperty notify change. Its navigation is at the page level, not at the view model level. And they have a concept of binding, but it's a different, the word binding means something completely different than the MVM binding that I'm used to and maybe you're used to as well. So what we do is we create view models in order to give us the MVVM pattern. We put minimal code in our code behind as we would on a mobile app. To implement binding, we use a different method. We make direct calls to the view model rather than the binding command that we see in a mobile app, and I'll show you that later. and we implement a view model level navigation. The reason why we do this is so that the code that we write, we can share across to our mobile app. Our first system, we didn't do that, and therefore, when we came to build the same functionality on the mobile app as we already had on our web app, we had to start from scratch because we didn't build it as in the MVVM structure. If you are never going to use, never going to share code with Xamarin, then maybe you don't want to do the MVVM pattern. Time. I will show you some code later on that. Actually, no, I should show you that now. If I look at a subcategory page, ooh. Wow, slow. You can't see that, I can see. Let me. Actually, I think I'll cover that later. I'm going to kill that Visual Studio and I'll come back to the code later. Async programming, you don't get async programming out of the box. And you will need it for performance. So even on server-side Blazor, we didn't use async programming because we thought it was server development, but now we're busy backfilling async programming. You do need it in server-side Blazor. To get SignalR is not perfect, and to get around some of its chattiness, we've needed to put some processing on background threads. If you're going to be sharing your code with your mobile development, then you will definitely need async programming. You are likely to use async programming with your client-side WebAssembly version of Blazor. And I say likely because the client-side Blazor doesn't support multi-threading at all now. We're expecting that in weeks. It's not far away, but it doesn't do that already. And so we don't know this for a fact, but we suspect that if we don't have async programming, then we're going to have the same problem that we have on mobile devices of blocking the UI thread with long-running tasks. So my advice of what we're doing is implementing all of our code as async programming. Database access. So what we do is we have if you look at the diagram for server-side Blazor and client-side Blazor, on the server-side Blazor, we will be calling our SQL server directly, and on client-side Blazor, we call a REST service to get our data, and on mobile devices, we call SQLite. We update into SQLite. How we do that is we create an interface. We call it iData Services, and we implement on each of these three different platforms. We implement a different version of iData Services. So we use obviously dependency injection to do that, and so therefore all of our code above the data layer is independent of how it's implemented. I'll show you that in a diagram in a moment. The last thing to note is the API server. So the API server will run on your server for both client-side Blazor and your mobile apps. So they both need REST calls. We use .NET Core MVC controllers, the standard MVC controllers. And as I said, they both run on the server-side Blazor. And the API itself calls the server-side implementation of iData services. So this code here is the same as that code there. It executes the same code. If I go back to the diagram, what I'm saying is that there's a line here between our models and our data, and in there we implement iData services, and over here the implementation of that makes a REST call to our API server. Over here, the diagram's not so good, but there should be iData services on a line there. The model's called iData service, which make, and its implementations makes direct SQL Server call. And over on your mobile service called iData service, it writes directly to the SQLite database. On a mobile, we also have a sync server that we implement, and it does the background syncing to and from the same API server that we use for client-side Blazor. And of course, if you're implementing server-side Blazor, then the mobile will be calling that API. That code, the API, is exactly the same code. And I should point out, this model on the Razor server side is exactly the same code as this model, which is exactly the same code as this model. So they're .NET standard implementations that are built in built differently for server side, client side, and mobile side. Sharing code with Xamarin. So there's, broadly speaking, there's two ways of doing this. The first way is to have a separate solution for your web and your mobile app. And this is what we do. This is our preferred solution. And then within there, you share the code. You only share the code that you need, and we implement base classes, and those base classes are different on a web app compared to a mobile app, but they implement the same interface. The second way is to have a single solution, and within that solution have multiple projects. You'll have an iOS project, an Android project, or a client-side Blazor project, a server-side Blazor. You'll have a Blazor UI project. You'll have a Xamarin Forms UI project, and a shared code project. Now, jury's out with us as to using this second method. So we don't actually have any clients that warrants that level of sophistication. Most of our clients have a different implementation, a small overlap of the functionality from their mobile and their on their server, on their web app. So for example, the motorsport one, they definitely need a mobile app for managing the grid when they're organising, the order that the cars start in. So they need a mobile app for that, but of course that function is just not required on the web app. So there's usually that difference, and that's mainly the case for us. The bottom case, we have had a client in the past that they were an aged care facility software company. They had about 150 pages on their mobile app for their staff as they walk around the wards, and there was all of those functions had an equivalent on the server, and on the server they probably had probably 3 times that many functions for other things, but they definitely had 150 odd pages that were shared across the two. If you have a client like that, then the sophistication in this option is certainly worth considering. Now I'm going to show you a couple of problems, and then I'm going to show you the code for the two different solutions. So the main problem with sharing code across web apps and mobile apps is that Blazor and Xamarin actually do the same thing, but they do them differently. So we have a couple of examples here. So on Blazor, I think it's initialize, and on Xamarin, it's on initialize, or the other way around. We have navigation service in mobile. We have navigation manager in Blazor. We have different names for iProperty, notify changed, on navigate to is different, parameter passing, different. The solutions that we deploy are twofold. So obviously we use dependency injection where possible to be able to implement different instances. So for example, the iNavigation service. We create the interface iNavigation service and we use dependency injection to give a different implementation for the Blazor side that will call Navigation Manager, and on the server side it will, sorry, on the mobile side it will call whatever it uses for view model level navigation. The other two, I'll mention these two things. So polymorphic is what I'm talking about having two separate solutions. So if you've got a view model that inherits from a base class, and then that means that you can share that code as long as the view model implements what it does on a mobile side compared to what it does on a Blazor side. So the view model will have the same interface, and when you build it, it will work, but when it runs, it will actually execute different code. So that's a polymorphic approach, and that's the approach that we use. The inheritance approach is where it's actually the same instance of base view model. That means that every function like executing a command or navigating or initializing has to have exactly the same code that gets run at runtime for both of those. So you may handle that by having if tests for the different environments. You may have environment variables. You may actually have the same code. There's lots of different ways of handling that, but that's a complex problem. Now, a colleague of ours, Lachlan Gordon, is doing a lot of research in this area. So he's actually got a blog out on at the moment of how to do that. He's he's in the research phase. So he's actually got it working. He has for a number of weeks there, and it's quite a good blog of how to do that. I'll show you the code that these two examples. So let me find the right, this is probably the right one. Yep. So I'm going to get rid of this modal page that we started with. Oh, I'm going to save that. And demo, I'll get that. Cool. And I'll get rid of this. So if we look at our two solutions, I hope that's big enough for you to see. I've got two projects here. I've got the mobile mobile project or mobile solution, which has iOS and Android in it, and the .NET standard project there. And on Blazor, we have the web, the client side, and the equivalent .NET standard. So you'll see in the Blazor side, we have some familiar candidates. We have views, view models, helpers, exceptions. We have database records for our three-tier architecture. So let me show you the equivalent on the Xamarin. So we have same deal. We have our models, views. We don't have databases there. We have DTOs. Now, what I wanted to show you is this one here. So I've created this folder, and in here is a class called Client Videos View Model. So this wasn't in the original build. I've just put it in for the demonstration purposes, but hopefully you will see what I'm talking about. So if I look at the Blazor side, we've got a whole bunch of view models there and this one here. Now this is the actual source, and this one here is at the operating system is an alias of this. So it's actually the same file. So we alias across the files that we want to share. And then you'll notice that this inherits from base page view model, and the instance of base page view model on a mobile is view model is this one, and this will have in it stuff that you're probably very familiar with if you're mobile developers. So we use Prism. No, Michael, you're there. You probably don't like us using Prism. No, I'm just kidding. And when on the Blazor side, we have a completely different version of base page view model. This actually looks nothing like the other one. I can put them side by side, but there's not much point in doing that. This is all Blazor, so it's got Matt Blazor in it. It's got it does things quite differently, but it's the same view model that we're sharing here. And sorry, what I should also show you is the difference in the view that this services. So I'll go back to a project here. So on the mobile side, we have a view, we have the client videos, XAML. Now, you'll have to ignore my errors there because I just never resolved them, but that's not my point. My point is to show you the difference between the code. So client videos Razor. So let's put them side by side. So the Razor code is on the right-hand side. So basically HTML tags. It'll have the same methods that get called here. So this, actually, I wanted to show you earlier. Make it a little bit bigger. So I wanted to show you earlier, whereas on the mobile side, we would I'm having trouble with the mouse, sorry. Whereas on the mobile side, we would be saying for these fields, bind to the title within your in this case, it's be a list of videos. So the syntax is binding with whatever context to the value, and on Blazor, we don't bind. We actually, the @ sign is the breakout to C# code, and then we say context dot title. So we actually don't use binding. We actually are using the field directly. Probably it shows better here. So the table itself, we're binding to the view model dot videos, so a list of videos. So you can see here there's no bind syntax. We actually say this item equals the view model dot videos. So the syntax is different, but the result is the same. This is this works because we don't have multiple platforms that we're serving up to. So, for example, on Android and iOS, it's quite different, but here it's quite okay. It's quite safe to do that. So that's a difference. So basically, the syntax is very different. So here is HTML, and on the Xamarin side, we have grids, and we're using a collection view there, but the functionality is effectively the same. All right, now I wanted to show you the alternate side. So the main point here is that we're sharing code there. I'm giving you an example of the view model that we're sharing, but of course, all of these models here, the category through to video, you'll find that over here, the category through to video, there's more up on there. Oh yes, because there's reporting a couple of other models up there. But in this particular case, they're not aliases. That's just because I haven't done that, but they would normally be aliases, and the content within them are identical across the mobile and the Blazor. Now, the question you will find when you actually try to do this is whether you want the database layer to be exactly the same. And generally, we find that they're a little bit different. The database that you want to store on your SQLite database in your mobile is not likely to be the same database structure that you're going to have on your server side. So whereas the models are different, the databases may not be. Let me move across, I'm very wary of the time. Let me move across to the other example where we're sharing the code. So if we look at the solution here, what I've got, so what I haven't done here, and you would need to do this if you were serious about this, is you would do nested projects rather than having single level projects in here. So you would have 3 projects at this level: a platform project, a UI project, and a shared project. And underneath the platform project, you would have 4 projects called Android, client-side Blazor, client-side startup, iOS, and web. And same on the UI project, you'd have 2 underneath that, a Blazor one and a Forms one. And the shared one, we just have the shared code. So in the shared one, I've got databases, DTOs, models, model services, the fluent validation stuff. And on the UI forms, this is just the normal, the platform level. For iOS, it's just your normal iOS project, client side. These are just copied from the previous project, so there's nothing outstanding there because they're the ones you actually build. Now it's the shared ones. So the shared ones, that's fine, that's a .NET standard project. Now these ones are a little bit tricky. So this is where you put anything that's Blazor specific, so Razor specific, I should say. So they're mainly your views, but there's a bunches of helper classes that you'll need and services that you'll need on the UI Blazor side. I'm not going to open them up because I know that it hasn't got the it's got more in there than needs to be there, so I don't want to give you the wrong impression. Same on the forms side. You will need forms, but you'll probably need some helpers there as well, and you'll need your custom controls and your converters and that sort of stuff. Now, let me go back. As I said, for that later example of sharing projects, Lachlan is the is the guy doing the most. And I should say, so he's from Melbourne, but I should say he's the one doing the most amount of work in the world on this. Questions. So I just want to re-mention what I've covered, and then so we just to prompt you. So there's Razor syntax, Mat Blazor, dual server-side, client-side Blazor, MVVM, async programming, iData services, and sharing of code. Do we have questions? Look at that, Alex. It's 7:30. We're right on the knocker of an hour. Oh, that's a bit long. Sorry.
Yeah, so we've got a handful of questions.
Cool.
First one that there has been a bit of a response to in the chat window already is it responsive, or how do you make it responsive? So the answer to the question is yes. So responsive, you do that exactly the same way that you would in an ordinary HTML project. So let me get rid of this and I'll show you. This will be very familiar with you. The person who asked the question, this will be very familiar. So I'll grab the web version here. So we have a CSS. We actually use Sass, so it's compiled CSS for those unfamiliar. And in our base class in here, I think it is, we actually define. So these are all our variables, but we define in here what our sizes are for each of the responsiveness. So we have a 25%, 50%, 70%, 100%. So this is not, it's a very good question because there's nothing amazing about this. This is what you do on any website. This is nothing unique here. So what happens is that there are, I actually haven't used this and I haven't modified it myself, so I can't actually tell you how it works, but effectively as you change the size of your screen, it'll execute one of these and that will actually change how many items are on your screen. So the answer to your question is yes, and it's standard web stuff. All right, cool, thanks for that. Next one is the projects that you showed where you were sharing code between Blazor and Xamarin. How much code would you say was shared overall? If you have any kind of metrics on that.
I don't really. So it depends on the project. If for the view models, no, look, it's just too hard. If for the TechFlix example, there's none because it's a video streaming service that we're not doing on the server side. So there's actually no sharing there. No, we actually do share all of the models. They're all identical. All the business rules for the models, they're all the same. So on that project, maybe 10%, 20%. In the example that I gave of the aged care facility, that would have to be up around the 60% of the 150 odd pages. You'd have to say that would be getting up to 50, 60% sharing. So it really depends on your project. Okay, that sounds good. Thanks for that. One more. There are a couple more. I'll probably put one more to you now and then maybe point you at the chats during the next presentation, just for time's sake. But we have one question. Have you hit any antivirus issues downloading your WASM DLLs? No, I've never considered that. So the DLLs are loaded from our server up to the browser. So antivirus, yeah, actually. So I was talking to a guy today over in the States, and his problem was that, oh no, I was actually here in Melbourne. His problem was it was an enterprise site, and they had firewall restrictions. So they're trying to get around that. And the problem wasn't the firewall, wasn't the DLL, it was the chattiness of Signal R and that being trapped by the virus protectors. So no, we haven't, but I have to caveat that we haven't got a production WASM WebAssembly site out there. So our sites are just our WASM sites are just internal at the moment. WASM's not ready for production deployment, in my view.
Okay, all right, good answer. So there are a handful more in the live event Q&A. So if you're able to hang around, Rod, and just maybe have a scroll through those, maybe during the next talk, that would be great. But other than that, on behalf of everyone listening, thank you very much for that talk. We've had a lot of good feedback from it, and clearly a lot of preparation went in. And I did just want to say as well that I haven't said at these meetups yet, but as the community, we're always grateful for people putting themselves forward to speak, always have been at these kind of events. But I think especially so now, when the people giving the presentations are really having to adapt to a new way of presenting and learn a whole lot of new skills. And you've got that, you don't have that instant audience feedback just from facial expressions that you're used to. So yeah, thanks Rod for that. And moving on then, thanks Priyanka for putting yourself forward as well. So I'll skip to Priyanka's introduction now. So Priyanka works with Michael over at XAM Consulting, and she's going to be telling us now all about what's new in iOS 14 and Xcode 12. So I'm about to put you live, Priyanka. It takes about 10 seconds to do the switch, publishing in Teams. Okay, you're good to go. Over to you.
Thank you, Alec. Thank you, Rod, for the amazing session. Now I'll just share my screen. Alec, is it all good?
It will be there any second now.
Okay, cool.
Okay, you're up.
Okay, hello everyone. I am Priyanka Gyawali. I currently work at XAM Consulting as a mobile application developer. I actually started my career as an Android developer, and then I got really fascinated with the Swift language, and I started learning, and currently I'm doing both. So this session will be all about the new updates that we have in iOS 14 and Xcode 12 and how, as a developer, we can leverage it. So moving forward, here we can see that with iOS 14, we have a lot of new updates, from widgets in our home screen to app clips, making us really easy to access application without even downloading it. And app libraries, picture-in-pictures, app translate. So there are a lot of updates that have come up. And this year, WWDC event, it took place as a digital keynote. And there were many announcements focusing on iOS 14, iPadOS 14, watchOS 7, and Big Sur, and most notably the Apple Silicon. But from a developer perspective, we will be talking more on Xcode 12 and iOS 14. So I'll move ahead with some of the notable updates. Apple introduced an online app store lab. So as a developer myself, whenever I face any problem, more than the Apple community portal, I choose to look up in Stack Overflow or just Google it. But because Apple haven't really proved to be helpful in the community portals, but this time we have some good news, because Apple have launched the App Store Lab, where it is really encouraging developer to share the feedback. So we will be able to give our updates on the App Store experience, and there will be virtual labs. So this is something that I am looking forward to it. And other is the App Store review process. As a developer or just if you're in a team of launching a iOS product, you may have faced the review process is really painful. Like for the same app, if you upload in the Play Store, it takes just a matter of 2-3 hours. But in iOS, there are a lot of steps that we have to go through, from just checking the screenshots, sizes, to the description of what we put into. So there are a lot of things, and the review process, in order to hear back from them and to give any feedback on why our build failed. So these kind of things take a lot of time. But this time, the good news is that as a developer, we can even challenge the App Store guidelines and the App Store violations. So when I worked in a fintech company, we used to create banking applications, and as App Store asked us to put the user credential there. So while working on those crucial products, there are some security that we don't want to, privacy policy that we don't want to expose even when we send it for reviews. So for those things, the App Store team, they do connect to us, and they do understand our motive, but still that process takes a lot of time, and it goes on for like 2-3 days just to hear back from them. But what we have been seeing now is that, if you can see here, in just a matter of 3 minutes, app is in sale, ready for sale from review process. So it's not, I'm not saying that we need to be really happy that it will just take 3-4 minutes. It really depends on the project size, how big it is, but we can clearly see that they have improved a lot. And one more thing I would like to mention here is, for our existing apps that are in App Store, and when we try to resubmit the bug fixes that we have been doing, it also used to take some delays over the guideline violation. So now we will be able to address the issue in our next submission, and we don't have to do a whole new submission for that. So this is something that would really make the product development process really efficient. And moving on to next. So Apple also announced that they are increasing the internal team member of test flight to 100. So it used to support just 25, and now what they have done is it allows 100 internal members. So those members can be assigned as account holder, admin, or app manager, developer, anyone, so that they can quickly test beta builds, and they can iterate the app. So each member can test up to 30 devices. And for the external testers, they have increased the size to 10K. So we can just use their email, or just by the public link, we can share it to more than 10,000 people. So in the new update, we have heard a lot about the privacy practice that Apple have announced. It is allowing developers to have the option to detail their app privacy practice directly in the App Store, like whatever data that we are collecting, we can share with the users in the App Store. So this is how it will come up now. So if some app is tracking your location, contacts, browsing history, purchases, you would be notified of all of that. And I think this is one of the major steps that Apple took to ensure its security. There is one news actually that TikTok has been copying from the clipboard, because earlier we didn't know how they were doing that, but now with iOS 14, you can see the notification whenever some app tries to copy something or access your system, then you'll get notified. So with that, it will bring a lot of security in Apple devices. And as a developer, we need to be really careful, as all these things are to be noted down. We should really focus on what type of data that we are collecting and ensure all those are mentioned. This is actually the Xcode 12, how it looks like. Here you can see that among all the updates that Apple brought, this time we have Xcode 12 beta that can create universal applications. So by universal application that they have mentioned here, what they really mean is support to both Intel and ARM based Mac. So with the development of Apple Silicon, the projects that we create from Xcode, it will support both the applications that are utilizing Intel and ARM based Macs. And what most of the developers are maybe thinking is without even downloading the Big Sur, you can actually download the beta version of Xcode 12 and get your hands on. So you can still use your macOS Catalina to work and see how Xcode 12 is. I have been using Xcode 12 beta for some time now, and some of the capabilities that it has is really, really nice. So these are just the minor things, but as a developer, that will have a bigger impact on us, like easy switching and a really user-focused interface for code completions, and the simulator performance is also really fast now. But whatever developers have been doing in Xcode 11, they will be doing the same in Xcode 12. So there's nothing major that you need to learn when moving to Xcode 12. These are just some UI UX changes that are just for your betterment. We will see how the Xcode 12 looks like in coming demo. Here, I'll be talking about Swift UI, as Apple have introduced a new lifecycle APIs with Swift UI. It allows developer to write entire app in Swift UI and share the code across all the Apple platforms. So it is also allowing developer to use the same code base to build highly talked about widgets, app clips, all the updates that Apple have been providing in new iOS 14. Those things we can create using Swift UI. So here I'll be giving some demo on widgets, grid view, and exporting files, and App Store overlay. These are the new updates that Apple have introduced with Swift UI. I'll just show. Okay, so this is the Xcode 12 beta version. Creating a new project. Here you'll see multi-platform option as well. This is something new. So what it does is we have this option of iOS, macOS, and multi-platform. If you select multi-platform, then it will provide both iOS and macOS support, and it will create a shared folder as well. So whatever is specific to macOS, you can write it in macOS, or whatever it is specific in iOS, you can write that in the iOS folder. Otherwise, in the shared folder, the same code base will work for iOS application and macOS application as well. For now, I'll just do iOS, and I'll create a project. So with Swift UI, grid layout has been made really easy. Here we will have app delegate, scene delegate, and this is the content view that we'll be working on. And this is something new. This is the preview screen, so we don't need to run the simulator every time. If you just resume and play this, we can see the preview, live preview of what we have written here in code. So we won't be needing this for the grid view. So the best way of, for now I'll just keep it that way. So in iOS 14, Swift UI have gained more power with grids, both vertically and horizontally, and it is really better than the lazy var that we use. That is, whenever our content is scrolled onto the view, it gets made, not before that. So that increases the performance, and it provides maximum efficiency. So the possible grid that we can make here is of numbers. So I'll just start with creating a variable data. Let's say till 100. I'll just map it in string and print it as declare a column. So in this grid item, we will choose adaptive. What it does is it just utilizes all the cells that we have. Yeah. Now we will create scroll view to make it scrollable, and call the lazy grid. So our column is columns that we made. Alignment is center. It's fine. Spacing, we'll give a spacing 20. We won't be needing this. So for each data that we have, we will look through item, now we will add the items here. So now I add some padding. Okay. Of this Sorry for that. Scroll view. All good. Yeah. Now if I just, okay. Oh, I have to add a padding. I'll just add a horizontal padding without any units. Should be good now. So when we do the preview, it will just do the build. It won't run the simulator. Here we will be able to see what we have created. Because this is a beta version, it may take time. So this is how it looks like. Now let's try to run it in a simulator. So what happens when we do this in Swift UI is we don't need to worry about any constraint or auto layout. The same code that we have here, it will work in both vertical and horizontal. So if we see here, we have just 3 columns and all scrollable. If I just rotate it, you'll see the columns are now 7. So the same code base we can use for iPad, watchOS, everything. So this is Apple's way of encouraging developers to do functional programming, just like React, using the same code base, and instead of having to think about all those constraints, we can directly do these kind of things. Now moving on to exporting a Swift UI. I have one demo already ready for this one. If I just open it in Xcode beta. Here I have already one test PDF saved for this demo. What we are gonna do is introducing this environment and export file. So with this, what we can do is we can perform this export action that's given by Swift UI, and I have this button called export file. This test.pdf is already here. So whenever we do the export, we have this 3 success, failure, and none. So when you usually don't do anything, then we will just print cancel. Let's see how it is. So earlier we just had a web view option, but now if you see here, we can even create a folder. Let's say test and move to test. Let's see how it shows. So yeah, you'll see a folder test and you'll see your PDF here. So this is something new that Swift UI have introduced. It lets us save our file from our app to anywhere where the user wants, like iCloud or custom folders. Now moving on to Okay, sorry, I'll just open up the test app. Here I already have this. Now we will start to see about App Store overlays, what they are about. App Store overlays are simply what we see in app clips, like whenever you can even recommend application from the bottom of the screen, you'll see one pop-up of the app, and when you click that, it will redirect you to the App Store. App clip is what it is all about regarding that. Oh, no scheme is selected. Okay, this is a beta version, so there are some bugs that doesn't show up, but never mind, we will move ahead. So yeah, exporting file, grid views, and App Store overlays, they are the new features that Apple have introduced in Swift UI. I will share the code for this one, what we have. With the App Store overlays, I couldn't share it in simulator, so I have this video that I can show you guys. So if we click on the show recommended app, it will pop up like this from the bottom, and whenever the user click it, it will redirect it to the App Store. So this is similar concept with app clip. So with just few lines of code, we can utilize this feature of app clip. Without any further ado, I'll continue with this. And more than that, Swift UI and Core ML, the new introduction of APIs in this have created major changes in technology, like natural vision and NLP with additional tools in Core ML for model deployment and encryption. They have been really emerging. We don't have all those in beta version. Whatever we saw in WWDC, that's not included in Xcode 12 beta, but we can expect it soon. In 1-2 months, we will be able to utilize all these APIs that we have. And Apple have also introduced Pencil Kit, new features in Pencil Kit. So the new OS can turn your handwritten words or anything into typed text. You may have also heard about a new feature called Scribble. So it will now become easy to create application with just entry fields. And it is also mentioned that developer will also have access to stroke data using Pencil Kit, all while seamlessly handling the Apple Pencil input and system touch gesture. Most of the developers use Pencil Kit while working on iPad projects. So here we have this UI pencil interaction. It gives Boolean. So it says that we can detect if the user is using pencil or touch gesture. So with that, we can create more interesting applications using Pencil Kits. Now moving on to ARKit 4 and Reality Kit 2. So Apple have introduced a new depth API designed to work with LIDAR sensor in iPad Pro. It enables a whole new range of apps such as designing, landscaping, and manufacturing. Moreover, Apple Maps integration for real-world location anchoring and face tracking without the true depth camera. They are also being introduced. I have one demo for this. I have used Reality Kit 2 for this project. So if you see here, what Apple supports now with ARKit and Reality Kit is videos as well. Earlier, we just had option of photos. It would just support photos, pictures, but now it is also supporting videos. Here, this is the view that I've created in the AR view, and I have one Spawn TV function. What it does is we just create a TV screen. So it's just a TV housing. We give size to that and color, and we create an entity. So within that TV screen, what we do is we just add our video there. So I have created one anchor to place on the wall. So this is our TV screen mesh, and this is our housing entity. So I've just added anchor in this housing entity. What it does is it will only run in real devices, not in simulator, because if this code wouldn't support to run it in simulator. And whenever you just tap using this tap gesture recognizer, we call this function handle tap. And with that, whenever user tap, we play the video. I already have one video here, demo video short.movie. So whenever user click that, we will be able to see the video. For this, I won't be able to show on the simulator. That's why I already had a video capture for that. So if you see here, so it is taking time to detect the edges, and after a while you'll see a screen there. There you go. So this way we can have a video support as well in Reality Kit 2, not just images. We can do a lot more with this. So in this example, you can see just one tap in the screen, in the TV screen that we created. We can embed our video there. So this is how it is done in Swift UI using Reality Kit 2, Reality Kit framework. Now moving back. Apple have also introduced AirPod Motion API. It is still yet to be able to work on the beta version, but that will allow us developer to assess the real-time movement of data. So wrapping up everything that we have discussed so far, online App Store Lab have been introduced, and the review process, the deployment will be really smooth from now. The test flight internal and external members have increased, and the privacy policy of iOS application has really enhanced with the new privacy practices that we have to implement. And with Xcode 12 and using the Swift UI new APIs, we can seamlessly create apps that can work on watchOS and iPad and iPhone devices as well. So Apple have really focused on making Swift UI a powerful language. They were working on that even before Swift was introduced. So it's like 10 years back, they have been working on this Swift UI grid capabilities and all of this. And so this is something really interesting that we get to learn, and I think in coming days for an iOS developer, learning Swift UI and knowing functional programming would be really essential, because we don't have restrictions of specific platforms. Like we have a lot of options from watchOS to tvOS. There are a lot of things. So if we have one single code base, that makes it really easy for us to create applications on different platforms. In Swift UI, like in the grid view and exporting of files, making it really easy for user to save PDFs, and the app store overlays, how we can use that in creating app clips, and more on the machine learning. We will have more APIs on the core ML side with the pencil kit and AR kit and reality kit, where will provide like a new dimension on how we work with AR. Now introducing videos as well. So these are just all of the notable updates that you should be aware of in the WWDC 2020 with iOS 14 and Xcode 12. This is me, Priyanka. We can discuss further. Whatever I've missed in this presentation, we can discuss about that as well. Back to you, Alec.
Thank you, Priyanka. That was a very thorough review of all those updates. Yeah, very detailed. Thank you very much. And yeah,
Thank you so much.
I echo my comments earlier, thanking Rod as well. It is really something else for speakers to put themselves out there in a brand new format. So yeah, thanks for that. Just before closing off, Rod has graciously hung around, so I'm hoping, if that's okay, Rod, if we just get you back on to answer a few of the questions that we didn't get time to do earlier, and then we can, there's a few people still around, but we can have them in the recording at least as well, if that sounds okay. All right, cool. So I will ask you a question. I think you're on mute, and if for some reason it won't let me unmute you. So I'll just fire one of the questions at you and then switch over to you. So we did have one about a fast framework. Let me just scroll back up through the messages to see if I can find it.
I did see that, yes.
Yeah, so speaking of material design, I'd be interested to know your opinion on the FAST framework from Microsoft. Did you have a chance to try it out yet with Blazor?
So I haven't actually even heard of it. So while Priyanka was doing her presentation, I had a bit of a look. It looks interesting. I'm going to have a look at it, but no, I haven't looked at that. And there was another, just to save you looking down there, Alec, there was another question
Thanks.
about model view update for Maui.
Yeah.
Again, head down, bum up. Didn't even see the relevance for Blazor. So, but I will have a look at both of those. I think they're quite interesting.
Oh. Okay, and that was actually it for the ones you didn't get to. I did have notes of some others, but you were right at the start of the presentation that you did cover them as you went through. So yeah, very well thought out. So yeah, just for those still around, I will do my best to edit this over the next couple of days. There's a bunch of chit chat from all the presenters at the start that I'll take out, and then I will post that. I'll probably tweet the link, put it on LinkedIn and in the meetup. So it just remains to send a big thank you again to Rod and Priyanka. Thanks also to Michael Ridland, who co-hosts these events and helps monitor the chats and Q&A behind the scenes, and get in a quick plug for Fresh MVVM, which we all spotted. Yeah, if anyone listening has ideas for any subjects they want to hear spoken about, or if even better, anyone is a budding presenter and wants to try their hand at this from the safety of their own home, then drop me a line. You can reach me on Twitter and or via the meetup group, and I'll put the links for that in the video as well. So it just remains to wrap up. So thank you again. Thanks for coming, and good night.
Thank you.
Thank you so much.